Namaste and welcome back to JEE Mathematics with Typical Monk. This is class 32. Differentiation. A limit tells you where a function is heading. A derivative tells you how fast it is getting there. Geometrically, it is the slope of the tangent, the steepness of the curve at a single point, found by letting a secant line pinch down until its 2 points merge into one. That one idea powers all of calculus. Velocity from position, the peak of a curve, the best approximation to a messy function. Learn the definition, then the handful of rules that make it quick. Power, product, quotient, and chain, and differentiation becomes almost mechanical. Today, the derivative, its rules, and the standard results. One idea at a time. Here is what you will master today. First, the derivative and its meaning. Second, differentiation from first principles. Third, the rules, power, product, quotient, and chain. Fourth, the standard derivatives. And fifth, the derivative as a rate of change, one idea at a time. Let us set the foundation. A derivative. It measures how fast one quantity changes with respect to another. The slope. Geometrically, it is the slope of the tangent to the curve. First principles. It is the limit of the average rate over a shrinking interval. Master line. The derivative is a limit, and the rules just make it fast. Now look at the picture. The derivative as a slope. The derivative, it is the instantaneous rate of change of y with respect to x. The secant, it is the slope of the line joining 2 points on the curve. The limit. As h tends to 0, the second point q slides in toward p, and the secant becomes the tangent. The slope. So the derivative is the slope of the tangent, dy by dx. Now, the derivative from first principles. The definition. F prime of x is the limit as h tends to 0 of f of x plus h minus f of x all over h. The meaning. It is the slope between 2 points as they merge into one. The example. For x squared, first principles gives 2x. The notation. We write it as di by dx or as f prime of x. Now, the rules that make differentiation swift. The power rule. The derivative of x to the n is n times x to the n minus 1. The sum rule. The derivative of a sum is simply the sum of the derivatives. The product rule. uv differentiates to u prime v plus uv prime. The quotient rule. U over v gives u prime v minus uv prime all over v squared. The chain rule. dy by dx equals dy by du times du by dx. Now, look at the picture. The rules, gathered in a table. The power rule. The derivative of x to the n is n times x to the n minus 1. The product rule. uv differentiates to u prime v plus uv prime, never the product of the two derivatives. The quotient rule. U over v gives u prime v minus uv prime over v squared. The chain rule. Differentiate the outer function and then multiply by the derivative of the inner. Now, the standard derivatives worth memorizing. Trigonometric. Sine x differentiates to cosine x and cosine x to minus sine x. And tangent x differentiates to secant squared x. Exponential. E to the x differentiates to e to the x, and a to the x to a to the x times the natural log of a. The logarithm. The natural log of x differentiates to 1 over x. Inverse trig. Sine inverse x differentiates to 1 over the square root of 1 minus x squared. Now why the derivative matters so much. The idea. The derivative measures an instantaneous rate of change. In motion, velocity is the derivative of position, and acceleration is the derivative of velocity. The applications. It drives tangents, maxima and minima, and approximations. Now match each rule to its formula. The derivative of x to the n goes to n times x to the n minus 1. uv primed goes to u prime v prime prime prime. The chain rule goes to di by du times du by dx. And the derivative of sine x goes to cosine x. 4 pairs, each worth memorizing. Now, how many of these statements are correct? Statement 1. The derivative is the slope of the tangent. Correct. Statement 2. The derivative of a product is the product of the derivatives. Wrong. You must use the product rule. Statement 3. The derivative of e to the x is e to the x. Correct. So the answer 2 are correct. Statements 1 and 3. The trap is the product in statement 2. Now, the 2 mistakes that quietly cost marks. The truth. The product rule is u prime b plus u v prime, not u prime times v prime. The trap. Differentiating a product as the product of the 2 derivatives. The second truth. The chain rule multiplies by the derivative of the inner function. The second trap. Forgetting that inner derivative in the chain rule. Now test yourself. Answer in your head before the reveal. That is how G-speed is built. Here we go. Question 1. The derivative of x cubed. 3x squared. Question 2. The derivative of sine x. Cosine x. Question 3. The derivative of e to the x. E to the x. Question 4. The rule for u times v. The product rule. And question 5. The derivative is the slope of what? The tangent. Let us gather it all in one breath. The derivative is a limit, the slope of the tangent. From first principles, f of x plus h minus f of x over h as h tends to 0. The rules, power, product, quotient, and chain. The standard derivatives, sine, cosine e to the x, and the natural log of x. And the derivative is, above all, a rate of change. Next class, the applications of derivatives, maxima and minima. The slope of the moment. The derivative captures a single beautiful idea, the exact rate at which something is changing right now. Geometrically, it is the tangent slope, born when a secant line pinches its 2 points into one. From the definition flow, the rules that make it swift, bring the power down, split a product, divide a quotient, and chain your way through a function inside a function. Learn the standard derivatives, respect the inner function in the chain rule, and you can differentiate almost anything on sight. Next class, we'll put the derivative to work, maxima and minima. Sarah, David, Lisa, and John all began exactly where you are sitting now. One idea at a time, you will crack G. I will see you in the next class.